All right, so we said that in the previous video we said that there are two types of semiconductor. Right, the first one we said we talked about intrinsic semiconductor, and number two we talked about extrinsic semiconductor. So what are the two differences between these two types of semiconductors? So intrinsic semiconductor, all right, we said that in the previous video that there are two forms of charge carrier. We have the positive holes, all right, we have the free moving electron which is negative, and we have the holes which are negative, which are positive. Free moving electrons, all right, in charge carrier is negative, while holes is positive. So now let's look at something very quick here. All right, now in intrinsic semiconductor, all right, it happens, of course, extrinsic is divided into two. There are two types of extrinsic semiconductor, all right. The two types of extrinsic semiconductor, the first one is what we call the P type, which is positive, it means positive, and we have the N type, all right. N type of what? Of extrinsic semiconductor. So extrinsic is divided into two. But intrinsic semiconductor actually happen when there are equal number of positive holes and negative free moving electrons. I'll come again. Intrinsic semiconductor is defined as a type of semiconductor where there are, or in which there are equal number of positive holes and free moving electrons. So when the positive holes, all right, when the holes and the free moving electrons are equal, all right, we call it intrinsic semiconductor. In intrinsic semiconductor, there is equal number of what? Of holes and what? And the free moving electron. Then in extrinsic semiconductor that I say is divided into two. It is a semiconductor that has a bare drop, all right. It has a bare drop in order to increase its conductivity. Bare drop in order to increase its conductivity. It's a type of semiconductor in which there is a bare drop in order to increase its conductivity. So those are the two types of semiconductors we have. Then I said extrinsic semiconductor are divided into two. We have the P type extrinsic semiconductor and we have the N type extrinsic semiconductor. And when the two are joined together, the two types of extrinsic semiconductor are joined together, all right, by a device called diode, all right. We call it junction diode, all right. So that is what we use in joining the two types of extreme semiconductor together. So now, once we said that in intrinsic semiconductor, all right, it happens, all right, it's a type of semiconductor where by the equal number of positive holes and free moving electrons. And in extrinsic semiconductor, it's a type of semiconductor in which there is a bare drop in order to increase its conductivity, and it's divided into P type, all right, P type extrinsic semiconductor and N type. So the P type is like a positive, while N type is what? Is negative, all right. So I'll state that, and I said that the device that connects them together, I'll still define each of the type of extrinsic semiconductor, which is P type and N type. So now for P type, when your P type, all right, of semiconductor, we can say P type is connected together. The device I said we use in connecting it is what we call diode, all right. It's at the center. So you have N type here, all right. Then your diode is at the center. What joins these two conductors together is what we call junction diode. Okay, we have junction diode here. Junction diode, all right. So junction diode or a diode is a device that connects the two types of extrinsic semiconductor together, which is the P type and N type. So what is P type of extrinsic semiconductor? P type semiconductor is an extrinsic semiconductor which contains, all right, positive holes as majority carrier and what? Negative free moving electrons as a minority carrier. So here at P type, all right, your holes are the positive holes are the what? Are the majority carrier, they are the major, while what? The free moving electrons are the what? Are the minority. So P type extrinsic semiconductor is a type of extrinsic semiconductor whereby, all right, your positive holes is what? Is the majority carrier, while negative free moving electron and the minority carrier. Then reverse is the case at N type. Reverse is the case at N type. At N type now, this your junction diode, I'll come to explain that. Your N type, all right, will now contain negative free moving electron as the majority carrier and positive holes as the what? Minority carrier. So here, your positive holes is the majority carrier, while negative free moving electron is the minority carrier. Here, All right, negative free electron is the majority carrier, you reverse it, while holes are the what? Minority carrier. And in the junction, you have what we call diode or junction diode. Okay. Now, at junction diode, what charge is there? What charge is there? All right, the charge that is in is at the junction diode um is like equal, all right? So because the junction has equal what? Positive holes and what? Negative free electrons. So there's no majority, neither is there minority at the what? At the junction, all right? So that's what we have as the p type and the n type. Now, okay, in also extreme in n type now, in extreme semiconductor, we can dope it, all right, now with whatever you use to dope or to increase the conductivity in the context now of a semiconductor. What we call it is called dopant. Okay, we call it dopant, or what is donating or donor. So there is also a current in the metallic conductors, all right, in semiconductor. Okay, and we have said, if you listen or watch our conductor video, resistor video, current in the metallic conductor is given to be NAVA. Okay, number of what? Number of electrons, then area, then this the velocity, and this the electronic charge. Electronic charge is equal to 1.6 times 10 raised to the power minus 19 joules. So if that's the case now, I'm going to be deriving that value of current for both of extrinsic and what? Intrinsic. So the total current of what in semiconductor for both my p type and n type for semiconductor is given to be I is equal to, so I have N, all right, of the P, all right, I have A, V, E of the what? Of the P, then plus, I'll add the current together. I have what? N, number of what? Electrons of the what? Of the N types, all right, N, then I have area, then I have V, then I have E of the what? E of the N type. So by the time I connect them together, all right, my NAV is the same, NAV is the same. So I can just use I is equal to N, let's say A, V, then I have electronic charge for the P type, then plus N, all right, A, V, and I have electronic charge for the N type. So NAV, all right, are the same. This one is for P and this one is for N, but number of electrons are the same. So I have I is equal to NAV. Then what is left? I have what? Electronic charge for the P type plus what? Electronic charge for the what? N type. That is the total current metallic conductor for. This is the general value for the current in metallic conductor, and this for it when you have it in what? In your extreme semiconductor. So that is that. Then lastly, we want to talk about biasing. Okay, biasing. All right, Zener. We also have what we call Zener voltage. I'm going to explain all of that, but we use diode majorly for amplification. All right, we use diode for junction diode for rectification. Rather, we need to rectify electronics. We need to rectify, but transistor eventually we use diode to amplify. All right, I'll talk about all of that. Okay, so now let's look at what we call Zener voltage, or let's talk about biasing first. Biasing. Now, when you hear the word biasing, all right, in semiconductor, what does it mean? Biasing is actually a way your junction diode can be connected to a circuit. Okay, the way your junction diode can be connected to a circuit is called biasing, and there are two kinds of biasing. There's what we call forward biasing, and there's what we call backward biasing. All right, backward or reverse biasing. Okay, backward or reverse biasing. Okay, now what happens at forward biasing and what happens at backward or reverse biasing? So in forward biasing actually, okay, I'll define it. Forward biasing is a type of biasing or occur when the positive terminal of the cell or of the battery, because we said the way your junction diode can be connected, all of this can be connected in a circuit, is what we call biasing. So now for the first, all right, your positive terminal of the cell is connected to the P type, all right? Positive terminal of the cell is connected to the P type, all right? Then, while the negative terminal is connected to the N type, that is what happens at a forward biasing, all right? The positive terminal of the cell, all right? I'll say it again. The positive terminal of the cell is connected to the P type, while the negative terminal of the cell is connected to the N type. Then when you get to the reverse biasing or the backward biasing now. All right, reverse is the case. Okay, for that, in backward biasing